Alright, welcome to today's class. In this class, I'll show you how first principle method of differentiation works. Now let's assume y is equal to x raised to power 2. If we are to differentiate y using general method, this is what we are going to have. Y all over dx equals 2x. Remember, you multiply x by its power and then subtract 1 from the power. So if you multiply x by 2, it will give you 2x. Then if you subtract 1 from 2, it will give you 1. So 2 raised to power 1 is the same thing as 2x raised to power 1 rather is the same thing as 2x. Now let's differentiate y using first principle method. This is general method. So we are given that y is equal to x raised to power 2 and we are asked to differentiate y. Our first task here is to add change in y to y and then add change in x to x. So we have y plus change in y equals x plus change in x and then all squared. So let's call this equation 2 and we'll call this equation 1. Our next task is to expand this bracket. So here we have x plus change in x all squared. First of all, x plus change in x all squared is the same thing as x plus change in x multiplied by x plus change in x. Now our next task is to multiply all the terms in the second bracket using each of the term in the first bracket. So we have x multiplied by x plus change in x close bracket plus change in x multiplied by x plus change in x. So x multiplied by x gives us x squared plus x multiplied by change in x gives us x change in x. And then plus change in x multiplied by x gives us x change in x plus x change in x multiplied by change in x gives us change in x squared. So we have x squared plus x change in x plus x change in x gives us 2x change in x plus change in x squared. So let's call this equation 3. Now our next task is to substitute equation 3 into equation 2. So if we substitute equation 3 into equation 2, we would have y plus change in y equals x squared plus 2x change in x plus change in x squared. Alright, let's move y to the right hand side. If we move y to the right hand side, we would have change in y equals x squared plus 2x change in x plus change in x squared minus y. Our next task is to substitute the value of y. Remember, y is equal to x squared, and we call this equation 1. So if we substitute equation 1 into this, we would have change in y equals x squared plus 2x change in x plus change in x squared minus x squared. So we have change in y equals x squared plus 2x change in x plus change in x squared. Now if you open up this bracket, you will have negative x squared. So our next task is to cancel out. We have x squared here and we have negative x squared here. So x squared minus x squared is 0. Now we are left with change in y equals 2x change in x plus change in x squared. Our next task is to divide through by changing x. So if we divide both sides by changing x, we would have change in y all over change in x equals 2x change in x plus change in x squared all over change in x. This can also be written as change in y all over change in x, 2x change in x all over change in x plus change in x squared all over change in x. So now change in x cancels change in x, and change in x cancels one of the change in x here. So we have change in y all over change in x equals 2x plus change in x. Now note this, whenever you get to a point where you have change in y all over change in x at your left hand side and you still have change in x at your right hand side, the next thing to do is to take the limit of change in x as 0. So take limit of change in x as 0. So if we take limit of change in x as 0, we would have change in y all over change in x equals 2x plus 0. Now what it means is that wherever you see change in x, substitute 0. So our answer becomes change in y all over change in x equals 2x. So this is our final answer.